So, I'm here at ESA Tech at Noordwijk in the Netherlands with the Euclid project scientist Rene Laureijs. I hope I pronounced your name correctly, Rene.
That's correct.
And we've been talking about the upcoming dark energy, the dark universe, dark energy, dark matter mission, which was initially meant to study primarily dark energy, but then it turned into also a dark matter mission. What's most exciting about this upcoming Euclid optical mission in space?
Well, very exciting will be the prospect of understanding dark energy in very detail and also seeing the dark matter distribution in the universe, of course, detected by Euclid. We will get beautiful, beautiful images of the sky in the optical and in the infrared as well, at wavelengths not accessible from Earth. So that will be a major breakthrough in the science we get from Euclid.
In the 25 years since, maybe a bit longer, since dark energy was detected, we really haven't made much progress in understanding it. How will Euclid give us a new insight?
Yeah, we have set out to have a accuracy in our dark energy measurement, which is of the order of percent, such that we can distinguish between different dark energy models. And the most adopted model at the moment is the model where you have 70% dark energy and 20% dark matter, 25% dark matter, and 5% normal matter. Now, we want to test if this model is really right or not.
And so will you be able to say, and also with dark matter, would you be able to say, rule out alternative physics in terms of dark matter?
Yes, our accuracy will be such that we can pinpoint the type of model we favor, and that would point it in a certain direction in physics. Dark energy, we think, should be the bridge between what we see from quantum mechanics, the standard model of quantum mechanics, and what we see by Einstein in general relativity. We hope to find a connection between the two by dark energy, understanding dark energy in more detail.
Would that help us determine the nature of quantum gravity?
Perhaps, who knows?
Well, listen, I really appreciate your time today. The launch is, you hope to be July 1st from Cape Canaveral on a SpaceX rocket.
Well, it's the beginning of July, and since it's the beginning of July, we just go for the 1st of July. But this is how we plan. Everything is ready at the moment at Cape Canaveral. The satellite is there. It has been shipped already. Tests are being done, and the last thing is the fueling of the satellite, which will happen in a few days before launch. So we are all ready. The big thing is, of course, seeing the data, and that is a major effort.
And the data, you said that's probably the biggest challenge, or the biggest job, is analyzing data incredibly.
Right.
And you hope to start doing hard and fast scientific observations with Euclid by December, maybe a little bit before.
Yeah, a little bit before December. We first have to understand the instruments, all the details of the instruments. And since our experiment, I call it an experiment, it's just not only a telescope, but it's really an experiment to measure the dark energy content of this universe. Our experiment need very accurate conditions of the telescope as well as the satellite itself. So these conditions will be measured. We call it calibration. And once we have all these characterizations of the calibration, we can correct our data such that we can measure the dark energy content.
Well, best of luck to you, and we look forward to hearing more about Euclid in the months and years ahead. Thank you, Rene.
Yeah, thank you.